Hello class! In today's video I'm going to be talking about molar conversions, and this is part 2. Previously we had a part 1 in which I went through the process for how to convert something in grams into units of moles, or vice versa. If you started in moles, you could find an amount of grams. In today's video, we're going to look at how we can use moles to convert to particles, or particles into moles. And then we're going to tie part 1 and part 2 together so that you can go grams to moles to particles. Some helpful videos for previous information. You should be familiar with information about the mole and molar mass. If you need a reference video for that, here is one of the videos that will help, the mole and molar mass of mine. And then it would also be helpful if you knew the information from Molar Conversions Part 1, grams to moles. Those are kind of the videos that have helped build the background of what I'm going to be talking about today. So first, earlier in the mole and molar mass video, we defined what a mole was. And we said in our definitions that this is a weighable amount of an element or compound, always contains the same number of particles. By weighable amount, I mean it's a nice bundle. It's a bundle of particles that we can put on a scale in order to get a mass. That's what I mean by weighable amount. You can think of moles as bundles of particles, and it will always have the same number in each bundle. Avogadro's number, this is the number of particles in one of those moles. So we have 1 mole is equal to 6.02 times 10 to the 23rd items. By items, I can mean anything. For example, if I was talking about 1 dozen, you might be familiar with 1 dozen to be 12. It does not matter what the unit is. I could be talking about 1 dozen is 12 eggs. I could be talking about 1 dozen is 12 elephants. I could be talking about 1 dozen is 12 donuts. That unit at the very end changes, but the relationship between 1 dozen and 12 stays the same. In a similar manner, 1 mole of anything is 6.02 times 10 to the 23rd items of whatever you're looking at. So, in chemistry, we particularly focus on, you'll hear the word particles, and I actually used particles up here in my definition. So particles tends to be a general term. A little bit more specific, you'll hear me talk about atoms. So we can use Avogadro's number in order to count an amount of atoms. And your atoms tend to refer to individual elements. For example, if I wanted to focus on just carbon, I have carbon atoms. Another example would be molecules. Molecules are referring to the non-metal bonded to non-metal substances. For example, methane, where you've got CH4, or water, H2O. Those are molecules that contain more than one element. And then just a technicality. I'm not going to get this technical, but I will use this vocabulary later in examples just so you've seen it. A formula unit refers to ionic substances, so those are your non-metals that are bonded to metals. For example, that would be your NaCl, your salt, your aluminum chloride, sodium chloride, aluminum chloride, any of those salt substances. So just to recap again for all of this, 1 mole is equal to 6.02 times 10 to the 23rd of any of these units. And we call that Avogadro's number. Because this is a relationship of two different units, I can rewrite it as a conversion factor. I can rewrite it as a fraction. So I could say that 1 mole is equal to 6.02 times 10 to the 23rd. And for the sake of being clear, let's just use atoms as my unit. So I could say 1 mole is equivalent to 6.02 times 10 to the 23rd atoms. It would also mean the same thing if I said it 6.02 times 10 to the 23rd atoms is the same amount as 1 mole. So those are two ways to write fractions in order to show this relationship. I will be keeping the same steps that I had in my Molar Conversions Part 1 video for how to convert between units. And these steps apply to any conversion that you're doing. I wrote them so they're general enough for any type of conversion, whether you're going kilograms into grams or anything else. So a quick recap on what those steps are. First, we want to write our conversion factor as a fraction. Our conversion factor are the relationships. So this would be molar mass as a conversion factor, or in the case of what I'm introducing today, we're using Avogadro's number as a conversion factor. And what I mean by write them as fractions is simply what we did up here. I just write them two different ways to mean the same thing. Here is another example in which I used the unit particles. The second step is that in your example, you want to start with your fact on the left side, then you write out the factors, or these fractions, these conversion factors. You use the one that would apply in order to cancel the units. So you start with your fact, cancel the units by using your conversion factors. And ultimately you want to get into the unit of what it's asking for, of the answer. And then the last step, once you have your units able to cancel, then we can plug it into a calculator. So we solve by multiplying any numbers that are on the top. So we times the top numbers. Any numbers that go down, we divide. So let's apply those steps with an example. Example 1, how many molecules are in 5.90 moles of ammonia, which is NH3? Step 1, write our conversion factor as a fraction. I've already done that up here, except now our unit that we care about is how many molecules. So I could just as easily change this unit to molecules. Now we need step 2, start with our fact, then use factors to cancel units. My fact is whatever information it gave me for the beginning unit, so that's going to be my 5.90 moles. That's what I'm starting in, and that is my fact. NH3. Then I use my factor to cancel units. I have gone through this several times, so I'll try to explain it a little faster. I don't want to stay in moles. I want instead to figure out molecules. I want moles to cancel. In order to cancel the moles here, the unit has to be in the opposite location. So here it's on the top. I need moles on the bottom in order to cancel it. So which of these conversion factors has moles on the bottom? Well, it's this one. So I'm going to end up taking this entire thing and rewriting it right here. So 6.02 times 10 to the 23rd molecules is equivalent to 1 mole. My moles cancel. I am left with molecules, which is what it was wanting me to find. So now I can move on to step 3 and actually plug this into the calculator. I'm not going to go into detail right now about how to plug numbers into a calculator using scientific notation, but on Google Classroom I have posted several videos as a reference, and you can look up on your own. So if you don't have access to my Google Classroom, you can look up on YouTube how to plug scientific notation into a calculator. For right now, I just want to focus on the conversion details. So 5.90 times 6.02 times 10 to the 23rd equals 3.55. The E is my times 10, and then to the 24th power. So 3.55 times 10 to the 24th, and this is units of molecules. So there's my numerical number, there's my unit. I also need the substance. My substance was NH3. I need all three of those details in my answer. Notice this is in scientific notation, so if you do not have a scientific calculator, please go get one, because otherwise you won't be able to do these calculations. All right, next I would like to give you an example to try on your own. So go ahead and try this one. A 0.75 mole sample of charcoal, which is made of carbon, contains how many carbon atoms? Pause the video and work through this example. All right, welcome back. All right, welcome back. Here is my worked out solution. So first, we want to write our conversion factor as a fraction. And in this case, because we're going between moles and atoms, I'm using Avogadro's number. So I can write them 1 mole over however many atoms, or 6.02 atoms over 1 mole. Then I want to write out my fact and my factors to cancel units. So my fact is going to be the 0.75 moles that I was given in the problem. My factor to cancel these units, I want moles on the bottom of my factor. So I'm going to use my 6.02, I'm going to use this setup where my 6.02 is on the top in order to cancel those moles and be left with atoms. When I plugged this into my calculator, I got 4.52 times 10 to the 23rd atoms of carbon. Hope that's what you got as well. Let's now recap a little bit of information. In my molar conversion part 1 video, I introduced something, at the very end of it, I introduced something that I called the mole map. And we had grams, which is our unit of mass, and we converted that into moles. And in order to convert from grams into moles, or if I was converting from moles into grams, whichever direction I'm moving, for that conversion, I used my molar mass as the conversion factor. That was something I introduced in an earlier video. Now, what I am suggesting in this video is that our moles can now be related to particles, and it can be related to any of these units that we saw earlier. So particles, I can relate moles to atoms, I can relate moles to molecules, and I can relate moles to formula units. And in order to relate moles into these units, if I start with moles, I can go that way. I can also start with these units and go that way. In order to relate that information, I use Avogadro's number. My 6.02 times 10 to the 23rd. because of this, so we started here in the, this was a previous video. In the video, the examples we just saw, we did this process. If we can put the two steps together, now we have a way to start in grams and determine how many atoms are in a sample. Or if I gave you a number of molecules, I could determine how much that sample would weigh in grams. So now we can go all the way from grams into particles and back. And in order to relate these two, you have to go through moles. Because again, moles was something we could weigh for a certain number of particles. So moles is the connection between mass and counting things by weighing. So now let's see an example for this entire process. What is the mass in grams of 1.92 times 10 to the 23rd formula units of sodium chloride? I'm going to start by writing out my conversion factors as fractions. So I have molar mass. The molar mass of sodium chloride is 58, and I'm going to abbreviate that as a capital MM, is 58.44. For the sake of time, I'm not going to step through how I solved that, but check out an earlier video on molar mass. So molar mass, 58.44 grams per mole. I can rewrite this as 58.44 grams for every 1 mole. Or I can rewrite this as 1 mole is in 58.44 grams. Those are the two conversion factors I can use. I can also use Avogadro's number. And we've seen these already today, where I write 6.02 times 10 to the 23rd over 1 mole, or 1 mole is 6.02 times 10 to the 23rd on the bottom. Those are the two ways I can write my conversion factors. My second step is to start with my fact. So my fact would be the 1.92 times 10 to the 23rd. Formula units for the sake of an abbreviation, and I apologize in advance, but I'm going to abbreviate this as FU, and I will put an S on that just for PC. So this stands for formula units, and I want to cancel my units. So my formula units, I need that unit on the bottom. So I would need this conversion factor because that's the one that's formula units on the bottom. Then my formula unit cancels with this formula unit. I'm left in units of moles. So I started here. I used my Avogadro's number to get to moles. It is asking for what is the mass. So I need to take it one more step further. So I have to use my molar mass to now convert it into grams. So my conversion factor next is going to be molar mass. And I want to cancel moles. Which of these conversion factors will help me cancel moles? Well, right now moles is on the top. I need my unit of moles on the bottom, so I'm going to be looking at my 58.44 on top and 1 mole on the bottom in order to cancel moles. Cancels with moles, I'm left with grams. That is the unit it is asking for, so that's the unit that I'm going to report for my answer. I've canceled all my other units. I've used my 2 conversion factors. So to check my work, I think I'm good to go and start plugging this into my calculator. So 1.92 times 10 to the 23rd divided by, this goes down, so I am dividing by 6.02 times 10 to the 23rd. And then it jumps up again. My 58.44 is on top. So I'm going to times 58.44. I get a value of 18.6 grams of NaCl. Here's another example that I would like you to try. A piece of solid iodine, which is I2, has a mass of 0.0245 grams. How many iodine molecules are in this sample? To get you started, I will go ahead and show you the mole map. So we are starting with our 0.0245 grams. You will need to use molar mass in order to convert into moles. And then you will need to use Avogadro's number in order to convert into your unit that it's asking for, which is molecules, iodine molecules. Something else to point out is that this is I2. So this is a diatomic element. Keep that in mind as you calculate the molar mass. All right, Okay, welcome back. Now let's go through what I have for my answer. So first I calculated the molar mass, and I did that by taking 2 atoms of iodine from the subscript. The 126.9 came from the periodic table. When I multiplied those, I got a molar mass of 253.8 grams per mole. I wrote those as 2 different fractions for conversion factors, 253.8 on top over 1 mole, or the 1 mole on top over 253.8 grams. I also, so that'll help me get to moles. The other conversion factor I need is Avogadro's number, so I went ahead and wrote those out. I am using the unit of molecules, so these are the 2 conversion factors that I have for Avogadro's number. For the actual calculation process, the fact was 0.245 grams of I2. To cancel my grams, I needed grams on the bottom, so I ended up using this fraction, this conversion factor, this setup, in order to cancel my grams. Now, that cancels grams here on the top with grams on the bottom. I am left with moles. Well, that's what my map should have said. So grams, use molar mass to get me to moles. Great. I'm not to where I wanted to end up, though. I wanted to go to molecules, so I do still need another conversion factor, which is my Avogadro's number. So right now I'm in moles. I need to cancel moles, so the unit moles has to be on the bottom. So I would end up using this one. So now these moles on top cancel with these moles on bottom. I have my unit of molecules left on top that has not canceled out yet. This was another factor. Notice, we could have calculated this part into the calculator, hit equals, and gotten a number of moles. And then we could have done this step. For the sake of time, and this is technically how I learned this method, you can chain all of your calculations together, all of your factors together, continue to add factor after factor after factor until all of your units have canceled. Okay, so the third step is to plug it into the calculator and obtain an answer. So when I plugged this into the calculator, I did 0.0245 divided by 253.8 times 6.02 times 10 to the 23rd, and that left me with 5.81 times 10 to the 19th. Again, this is units of molecules, and I want to specify that this is I2. To recap, if we're going from grams into moles, or we are starting in moles and going to grams, we're going to use molar mass. If we are trying to convert our units from moles into particles, atoms, molecules, or formula units, or if we're starting in any of these units and trying to get to moles, then we would use Avogadro's number, which is 6.02 times 10 to the 23rd. That would be our conversion factor. And if we need to start in grams and end here, or start here and end in grams, then we would have to go through moles in order to do that. I hope that was helpful, and hopefully by the end of this video you are able to convert using moles in any direction using this molar map. Have a great rest of your day.